India is a country where temples stand on every corner, ancient ruins punctuate modern cities, and stone monuments carry the weight of thousands of years. Tourists visit them every day. Historians catalogue them. Archaeologists study them. But there's something about India's oldest stone structures that doesn't fit the official narrative. Something that suggests we're looking at the remnants of a civilization that shouldn't have existed. Lock your doors. Put your headphones on, because after this you'll never look at ancient India the same way again. The Kailasa Temple in Ellora is one of the largest rock-cut structures on Earth. It wasn't built by stacking stones or assembling pieces. The entire temple, every pillar, every statue, every courtyard, was carved downward from a single piece of solid basalt rock. One continuous mountain transformed into a multi-story architectural masterpiece. Official history says it was built in the 8th century AD by the Rashtrakuta king Krishna I. That gives the builders roughly 18 years to complete it, according to inscriptions. Here's the problem. Modern engineers calculated that to carve the Kailasa Temple in 18 years, workers would need to remove approximately 200,000 tons of volcanic rock. That's roughly 30 tons per day, every single day, for 18 years straight. Dr. Ashok Kumar, a structural engineer and professor at the Indian Institute of Technology in Mumbai, led a team in 2009 to analyze the precision of the cuts. What they found disturbed them. The tool marks on the stone showed uniform depth, consistent angles, and parallel striations that indicated mechanical cutting, not manual chiseling. In his published report, Dr. Kumar stated, "The level of precision observed in the Kailasa carvings suggests advanced tooling capabilities inconsistent with 8th century technology. We attempted to replicate a single column using traditional methods. After 3 weeks, we achieved less than 2 of the required depth. If it took modern engineers with steel tools 3 weeks to carve 2 of one column, how did ancient workers carve an entire temple complex in 18 years with copper chisels and hammers? The math doesn't work, the timeline doesn't fit, and the tool marks tell a different story. But here's the thing. Kailasa isn't the only structure that defies explanation. In the town of Halebidu, in the state of Karnataka, stands the Hoysaleswara Temple. Built officially in the 12th century, it's famous for something engineers call impossible architecture. The temple contains several stone pillars that rotate on their axis. Not slightly, not with effort. They spin smoothly, freely, as if mounted on precision ball bearings. One of these pillars, known as the lathe-turned pillar, was examined in 1991 by Dr. Rajesh Rao, a mechanical engineer from Bangalore. He documented the pillar's rotational movement, analyzed its surface, and measured its symmetry. His findings were published in the Journal of Indian Engineering, but rarely discussed publicly. Dr. Rao found that the pillar's cylindrical shape was uniform to within 0.02 millimeters across its entire length. That's the tolerance level of modern CNC machining, not hand carving. He also found that the pillar's base was not anchored into the ground, but resting on a circular stone socket that allowed frictionless rotation. The socket itself showed concentric grooves consistent with lathe tooling. In his report, Dr. Rao wrote, "The precision required to produce this rotating pillar suggests access to rotational machinery or advanced knowledge of load distribution and friction reduction. This level of engineering is not documented in any known 12th century Indian text." When asked how the pillar was made, Dr. Rao said simply, "We don't know. And with our current understanding of medieval Indian technology, we can't explain it." But the precision doesn't stop there. In the village of Lepakshi, approximately 120 kilometers from Bangalore, there's a temple built in the 16th century that contains something engineers call the hanging pillar. It's a massive stone column that doesn't touch the ground. Visitors routinely slide pieces of cloth or paper underneath it to prove it's suspended. No wires, no modern supports. Just a 3-ton granite pillar floating a few centimeters above the floor. Structural engineers from the Archaeological Survey of India attempted to study it in 2001. They wanted to understand the load-bearing mechanics, the point of attachment, the stress distribution. When they tried to analyze the pillar's connection to the ceiling, they found something disturbing. The ceiling stone showed no signs of abnormal stress, no cracks, no deformation. The weight of the pillar wasn't being transferred in any conventional way. One engineer, who requested anonymity, told a journalist, "It's as if the pillar is weightless. The stone it's attached to shouldn't be able to hold that mass without visible cracking. But there's nothing, it's just hanging." The Archaeological Survey of India has never published a full report on the Lepakshi hanging pillar. When journalists inquired, they were told the investigation was ongoing. That was over 20 years ago. But if ancient Indian builders had access to advanced engineering techniques, where did that knowledge come from? The Konark Sun Temple, in Odisha, was built in the 13th century and designed to look like a massive stone chariot pulled by 7 horses. The entire structure was once held together not by mortar, but by a complex system of iron beams and interlocking stones. At the top of the temple sat a massive lodestone, a naturally magnetic rock weighing approximately 52 tons. According to historical accounts, this lodestone was so powerful that it disrupted the compasses of ships passing along the nearby coast. Portuguese sailors in the 16th century reported their navigational instruments malfunctioning when they sailed near Konark. The magnetic interference was so severe that it became a maritime hazard. In 1568, according to some accounts, a Portuguese fleet convinced local authorities to remove the lodestone. Once it was taken down, the entire temple began to collapse. Without the magnetic force holding the iron framework in place, the stones shifted, walls crumbled, and the structure fell into ruin. Today, only portions of the temple remain. But here's the mystery. How did 13th century builders in India understand the principles of magnetism well enough to use a lodestone as a structural keystone? Magnetic theory wasn't formalized in Europe until the 17th century. The concept of using magnetic force in architecture doesn't appear in any known medieval engineering texts. Dr. Meera Sharma, a physicist from the Indian Institute of Science, studied historical records of the Konark Temple in 2014. In an interview, she said, "If the accounts are accurate, the builders of Konark understood magnetic fields, load distribution, and ferromagnetic attraction at a level that shouldn't exist for another 400 years. That suggests either the accounts are exaggerated, or we're missing a significant chapter of scientific history." Yet the evidence isn't just architectural, it's geological. The Bhimbetka rock shelters in Madhya Pradesh contain some of the oldest known human artwork in India, with paintings dating back over 30,000 years. In 2002, archaeologist Dr. Vikram Singh was documenting the site when he noticed something unusual. Some of the cave walls showed signs of advanced tool use, smooth cuts, right-angle corners, and geometric precision far beyond what Paleolithic humans should have been capable of. But it wasn't just the walls. It was what was inside them. Dr. Singh's team discovered a series of small, drilled holes in the granite rock, each approximately 2 centimeters in diameter, and perfectly cylindrical. The holes were spaced evenly, forming patterns that suggested intentional design. When Dr. Singh analyzed the drill marks under magnification, he found spiral striations inside the holes, evidence of rotational drilling. The holes also showed no signs of hammering, chipping, or manual carving. They were smooth, uniform, and deep, some penetrating over 30 centimeters into solid granite. Dr. Singh submitted his findings to the Indian Journal of Archaeology. In his paper he wrote, "The drilling technique observed at Bhimbetka requires rotational mechanical force and, likely, harder than granite drill bits. Copper and bronze tools cannot achieve this. Steel tools did not exist in India 30,000 years ago. The question remains, what tools were used, and by whom?" The journal published his findings in 2004, but the paper received little attention. When Dr. Singh was asked in an interview what he believed made the holes, he paused, then said, "I don't know." And that terrifies me because it means we don't understand our own history. But the precision cutting isn't isolated to Bhimbetka. The Udayagiri caves in Odisha, dated to the 1st century BC, contain some of the earliest known rock-cut sculptures in India. Inside one of the caves is a carving of the Hindu deity Vishnu in his boar incarnation, lifting the earth. The carving itself is stunning, but what caught the attention of researchers wasn't the artistry. It was the base of the sculpture. The rock beneath the carving shows a flat, perfectly level surface spanning over 4 square meters. The surface is smooth to within a fraction of a millimeter, with no tool marks, no chisel scars, no irregularities. It's as if the stone was polished by a machine. Dr. Ananya Patel, a geologist from Jawaharlal Nehru University, examined the surface in 2017 using a laser profilometer, a device that measures surface flatness to microscopic precision. Her results showed that the rock's flatness deviated by less than 0.1 millimeters across the entire surface. That's the tolerance level of modern granite countertops, not ancient hand-carved floors. In her report, Dr. Patel wrote, "The flatness of the Udayagiri cave floor suggests mechanical grinding or polishing techniques. Achieving this level of precision manually would require months of continuous work with abrasive materials and constant measurement. No evidence of such abrasives or measuring tools has been found at the site." When asked how the floor was made, Dr. Patel said, "I can tell you what it looks like. It looks like it was milled. But milling requires machinery. Machinery requires an understanding of mechanics, metallurgy, and precision engineering, none of which, according to official history, existed in 1st century BC India. Yet the evidence keeps appearing. The Ajanta caves, carved between the 2nd century BC and 6th century AD, contain 30 rock-cut Buddhist temples and monasteries. Inside these caves are stone pillars, carved from the living rock, that are perfectly cylindrical, evenly spaced, and structurally uniform. But one detail disturbed archaeologists when it was first studied in the 1920s. Several of the pillars show evidence of advanced geometric knowledge. They are not simple cylinders. They are fluted columns with precise helical grooves spiraling up the length of the pillar. The grooves are evenly spaced, consistent in depth, and follow a mathematically perfect helical path. British archaeologist James Ferguson, who studied the Ajanta caves extensively, noted in 1880 that the helical pillars suggest knowledge of rotational carving techniques or use of templates that would require advanced geometric understanding. He could not explain how such precision was achieved. In 2011, Dr. Ramesh Iyer, an architect from Mumbai, used 3D scanning technology to map the helical grooves of one pillar. His scans showed that the helix followed a consistent pitch of 37 degrees across the entire length of the pillar. That level of consistency is nearly impossible to achieve by hand, especially when carving downward from solid rock. Dr. Iyer published his findings in the International Journal of Architectural Heritage, concluding the Ajanta helical pillars demonstrate knowledge of three-dimensional geometry, rotational symmetry, and precision carving that is inconsistent with the tools and techniques attributed to the period. But here's where it gets strange. If ancient Indian builders had access to advanced tools and techniques, why isn't there any record of them? No ancient texts describe diamond-tipped drills. No inscriptions mention rotational lathes. No historical accounts explain magnetic architecture. And yet the structures exist. The precision is measurable. The engineering is undeniable. So where did the knowledge come from? One possibility, suggested by researchers like Graham Hancock and Robert Bovell, is that these structures are remnants of a much older civilization, one that existed long before recorded history. A civilization with advanced knowledge of engineering, metallurgy, and mathematics that was lost during a cataclysmic event, possibly at the end of the last ice age. This theory is controversial, dismissed by mainstream archaeology as speculative, but it's supported by one undeniable fact: the dating. In 2023, the National Institute of Oceanography in India discovered underwater structures off the coast of Gujarat, near the Gulf of Khambhat. The structures included walls, foundations, and geometric formations that appeared to be man-made. Carbon dating of organic material found within the structures returned dates ranging from 7,500 to 9,500 years old. That's over 5,000 years older than the Sumerian civilization, long considered the cradle of human urban development. The discovery was groundbreaking. If confirmed, it would mean advanced civilizations existed in India thousands of years earlier than previously believed. Dr. S.N. Rajaguru, a leading geologist, examined the site and concluded that the structures were likely natural geological formations, not man-made. His assessment was published, and the discovery was largely dismissed by mainstream archaeology. But not everyone agreed. Dr. Graham Hancock visited the site and examined photographic evidence. In his book Underworld, he argued that the structures showed too much regularity, too much geometric precision, to be natural. He pointed to the consistent right angles, the parallel walls, and the clear foundations as evidence of human construction. The Indian government ordered further investigation, but in 2004, funding was cut, and the site was closed to researchers. Attempts by independent archaeologists to access the site were denied. Permissions were revoked. The underwater structures off the coast of Gujarat remain officially unexplored. But the implications are staggering. If the carbon dating is accurate, it means humans were building complex structures in India nearly 10,000 years ago. That predates the pyramids of Egypt by 5,000 years. It predates Stonehenge by 7,000 years. It rewrites the entire timeline of human civilization. And if that's true, then maybe the Kailasa Temple, the Hoysaleswara pillars, the Konark lodestone, and the precision-cut caves aren't anomalies. Maybe they're remnants of a knowledge system that's far older than we realize. Dr. Ashok Kumar, the engineer who studied the Kailasa Temple, was asked in a 2015 interview what he believed. He said, "I'm a scientist. I deal in evidence. The evidence shows precision, advanced engineering, and techniques that don't fit the accepted timeline." Does that mean there was an ancient advanced civilization? I don't know, but it means we need to seriously reconsider what we think we know about India's past. In 2018, Dr. Kumar submitted a formal request to the Archaeological Survey of India to conduct a comprehensive study of the tool marks, precision cuts, and engineering techniques found in India's oldest stone structures. His request included funding for a 3D scanning, metallurgical analysis, and comparative studies with modern machining. His request was denied. No reason was given. When he appealed, he was told the sites were protected heritage locations and that invasive analysis was not permitted. His appeal was rejected. Dr. Kumar has not spoken publicly about the Kailasa Temple since, but the questions remain. If ancient Indians had copper tools and hammers, how did they carve rotating pillars with CNC-level precision? If they had no knowledge of magnetism, how did they design a temple held together by magnetic force? If they had no rotational machinery, how did they drill perfectly cylindrical holes into granite 30,000 years ago? And if the answers exist, why are researchers being denied access to study them? India's stone megastructures are more than ancient wonders. They're evidence of something we don't understand. Something that challenges every assumption we have about the development of human civilization. Maybe the official history is incomplete. Maybe there's a missing chapter, a lost era of advanced knowledge that disappeared before writing, before records, before history itself. Or maybe the knowledge never disappeared. Maybe it's still there, carved into stone, waiting for us to finally ask the right questions. 6 structures. 6 impossibilities. The Kailasa Temple carved from a single mountain with tools that shouldn't exist. The Hoysaleswara pillar rotating on a precision axis like a modern lathe. The Lepakshi pillar floating in midair with no explanation. The Konark lodestone holding a temple together with magnetism centuries before magnetic theory. The Bhimbedka drilled holes made with tools harder than granite. The underwater structures off Gujarat dating back 10,000 years sealed away from investigation. If you've made it this far, thank you've made it this far. Leave a like if any of these mysteries stayed with you. Tell us which structure haunted you the most, and which one we should investigate next. But remember, some stones don't just stand, they remember.